Kokla ma'am, we can start the session, ma'am.
Okay. Good afternoon, everyone. First of all, I thank our Lord Almighty for this great event. Next, on behalf of Computer Science Department, I extend a very warm welcome to our resource person, Mr. Dilip Muralidharan, our chairman, Mr. Pon Robert Singh in his absence here, our principal, Dr. Nadarajan, our HOD, Dr. AJ Deepa, faculty members, and my dear students. I welcome you all for this virtual power seminar on data science and its applications. It's indeed a proud moment to our department as well as our institution. In this occasion, we extend our heartfelt thanks to our ICT Academy for their constant support and continuous effort. In this moment, I feel proud to inform you all that more than 350 members have been registered for the seminar, and apart from panel members, remaining will be viewed through YouTube link. Once again, we enlarge our warm welcome to Mr. Dilip Muralidharan, Star of the Day, for decorating this event with his gracious presence. Now, I request our principal, Dr. Nadarajan, to deliver welcome address and speaker introduction. Welcome you, sir.
Good afternoon, viewers. Very fine afternoon, and I am here to introduce the speaker of the day at the webinar on data science. With the advent of coronavirus, the entire world has changed. It has changed the way how we interact with the society, how we travel, on many aspects of our interactions with the world. We had to change our behavior. Such is the intensity of coronavirus. We have to change our behavior to a large extent. And learning also has become to have a change. Learning, it was earlier confined to classrooms and the textbook. Now they had to change because with no access to the classrooms, the students, they cannot stop learning and the teachers cannot stop giving them the knowledge. So in such a situation, this learning experience also had to undergo a transformational change. And this transformational change was identified early by our honorable chairman, Mr. Pon Robert Singh, who was very quick to understand the changed situation and to make the students continue to learn. So he was quick to adapt to the situation, and he encouraged and motivated all the heads of the department staff to adapt to the new environment. I am glad that the heads of the department and the staff, they have adapted to the situation and have risen to the expectations of the chairman. So I am really proud that we have a chairman who is a visionary, who is a motivator, who is constantly with us, giving all the support he can give. Now, in this direction, so most of the departments have carried out this webinars, and I am happy that glad that Department of Computer Science took the early lead and conducted few 3 or more webinars, and few are yet to come. And other departments have also taken the example, and they are also conducting these webinars. To that extent, the entire college is tuned to the new environment of giving information to the students. So accordingly, today the computer science department have planned a webinar on data science and its application. And we have with us Mr. Dilip Muralidharan. He is a seasoned professional working in the IT industry for the past 18 years. He is an experienced consultant in the educational and professional delivery space. He currently works as senior technical instructor in a company called Splunk, which is a data to everything platform, which is the world's largest big data analytics company. Splunk provides software and services in the area of security to analyze, protect, and automate infrastructure from security point of view, leveraging machine-generated big data. He is a Dale Carnegie certified instructor and has delivered on-site training to various multinational companies. So we are very glad to have with us a knowledgeable, experienced person, industrial person, to tell us about what is data science and about its application. So I request Mr. Dilip Muralidharan to take over the session and inform us about the topic. Thank you, and I welcome Mr. Dilip Muralidharan. I would like to take the opportunity to acknowledge the services of ICT Academy in this situation, and also the coordinator Isaac, who has been constantly helping the department to successfully execute these webinars. Now I request Dilip Muralidharan to take over this session. Welcome, Mr. Muralidharan.
Thank you, sir.
Thank you, sir. Thank you, everyone.
Now it's time to hand over the session to our speaker. I welcome you, sir.
Thank you, ma'am. Good afternoon, everyone. My name is Dilip. I am a seasoned education consultant. I've been working in the education and consulting business in the IT sector for over 12 years now. I've been in the IT industry for about close to 18 years now. And before getting the session started, I would like to thank the staff and the management of Pondicherry College of Engineering for putting together this session. I would like to thank the staff and the administration and management of ICT Academy, who's been putting together not just this session, but similar sessions on a weekly basis. So much kudos and appreciations to them as well. So today's subject of discussion is data science and its applications. So we're going to talk about what data science is, right? And what exactly are the applications of data science. So before we get started with the discussion as to what data science is, I'm going to give you a brief history, a synopsis about what is my professional history, where I come from, and also what exactly is the relevance of someone like me talking about data science, right? So that we can justify the agenda is going to go forward as far as this discussion is concerned. Now, like I said, I've been in the IT industry for about 18 years right now, 12 years in education and consulting. I worked mostly on enterprise software. I worked on technologies such as GPS-based fleet management systems long before GPS became a consumer technology, specifically based on phones. For the majority of my education career, I've worked on enterprise content management, supply chain management, and for the past 3.5 years, I've been working with Splunk. And Splunk is a big data analytics company. Arguably, Splunk is the world's largest big data analytics company. And I work in the field of big data. I work in the field of specifically data analytics. So our product delivers solutions to customers, and we help customers make decisions on the basis of data. So it's a big data product that not only is going to do basic data analysis, but we also have machine learning content packs, which allow us to implement artificial intelligence on top of large data sets, so that we can go ahead and implement any sort of predictive analytics, right? So we talk to all platforms, we talk to IoT data, we talk to sensor data, we talk to log data. Log data is where we started as a company, analyzing computer logs, device logs, but we do much more than that right now. So that is my background. That is where I come from. And generally speaking, I've been speaking with ICT Academy for the past couple of years, and it's been a pretty enjoyable experience. So with that being said, with a very short synopsis of introduction, let me quickly jump into the subject and let's talk about data science, right? We're going to see what exactly is data science. We're going to see what are the applications for data science in business. And I'm going to try and show you a quick demo. I'm not going to take anything more than 5 or 10 minutes to show you that demo. But I always believe in demonstrating something that I talk about. It's easy to lecture on something, but it's not easy to demonstrate what you're lecturing on. And I'm of the firm belief that if you demo something that you lecture on, it would make a lot more sense as to what that lecture is about. So in accordance with that philosophy, we are going to see one or two very quick demos on what are all the applications of data science, right? Now, so first things first, we're going to see what exactly is data science, what exactly is artificial intelligence, right? Now, data science, artificial intelligence, AI, big data, they're all related terminologies in the field of data science. So what exactly is, data science, right? Or what exactly is artificial intelligence or big data? Well, primarily speaking, data science encompasses big data. So that leads us to the immediate question, which is what exactly is big data? Well, in that case, what I'm going to have to do is let's actually go ahead and Google our way through this, right? And try and understand what exactly is big data. So let me share a browser here, and hopefully I will be able to. All right. So let me go to a simple web search and then search for big data. Little big basket is what comes up, my search history. All right. So maybe let's see what exactly is the classic definition for big data. So we have a Wikipedia entry here. And the Wikipedia entry, what does it say about big data? Well, it says big data is a field that treats ways to analyze and systematically extract information from, or otherwise deal with data sets that are too large or complex to be dealt with by traditional data processing application software, right? That's the definition here for big data. So let's go back here and let's talk about big data first, right? Big data, right, is nothing but it is the concept of dealing with not just massive quantities or massive volumes of data, but it is also the subject of dealing with complex data, right? Data that has a certain specific level of complexity, and that complexity is difficult for traditional data processing applications to handle. So the question then becomes, what are the traditional data processing applications? What kind of data processing applications have we been using before we started talking about big data? Well, we've been using data processing applications all throughout our lives. I mean, right from the early 70s, data processing applications have been the core of computing. So classic example for any data processing application that if you want to look at is the applications that you're already familiar with. So let's take, for example, Microsoft Excel, right? So Microsoft Excel, if I were to go ahead and if I were to look into something along the lines of Microsoft Excel, right? It's a very simple traditional data processing applications. What does it do? It deals with structured data. It deals with structured data and it deals with metric data. Now, any simple data that has a structure and that has a definitive metric to it, you can easily work with and you can easily manage using a data processing application like, Excel, Microsoft Excel. What does it do? Well, it basically manages spreadsheets. That's all it does, right? What else is an example for a data processing applications? Well, there are many RDBMS applications that are out there, Microsoft SQL Server, Oracle, Sybase, DB2. There's plenty of examples. I can keep naming on and on and on, but I mean, you get the logic, right? So these are all relational database applications. Relational database applications are also built to deal with structured data, and they are also built to deal with large quantities of data. Now, RDBMS applications used to be pretty useful and they used to be pretty on the spot in traditional business applications all along the line until the recent past. In the recent past, there's been a lot of changes that have come about in our lifestyle, in technology, in the industry, in the IT industry, and not just in the IT industry. Technology has actually largely influenced how exactly the traditional business environment works as well, right? So what do I mean by that? Well, what I mean by that is, you see, if you look at any business today, right? You take a normal business. Back in the day, 15 years ago or 10 years ago, the only thing that we could do if you wanted to buy provisions is you could go to the local provision store near your house, or maybe if you wanted to buy a lot of provisions and if you wanted a whole lot of variety of products, you used to go to, a big supermarket like Spencer's, or what is the other thing, Food Walk, or Foodway, something like that, right? So or Big Bazaar, whatever it is, right? Now, if you look at those businesses today, all of those businesses today are available on e-commerce platforms. And I don't think I need to, you know, impress upon you the importance of these businesses, especially in a time of, pandemic where we are all pretty much under, quarantine and self-quarantine and isolation in our homes. We've been trying to buy, our groceries and our vegetables and our meat and dairy products and supplies from these online platforms. And what is common with all these online platforms? All these online platforms leverage big data. They leverage big data so that they can understand the business, they can understand the customer, they can understand the behavior of the customer, they can understand the costing of the customer, all of these, right? And once this information is available to you, it's a very, very lethal piece of information, because if you understand customer behavior, you can not only predict sales, but you can also improve upon your sales as well, right? So that is what big data allows you to improve upon, right? Now, machine learning is another whole big part of, data science or artificial intelligence. So machine learning is essentially, at the end of the day, machine learning is nothing but complex statistical algorithms that are implemented in code. That's all it is, right? So machine learning is, you build an algorithm into an application and you use that algorithm on your production data, and you train your production data using that algorithms so that you can predict outcomes, right? Or you can analyze possibilities, right? So it's a logic-based approach or a pattern-based approach. That's basically what we do, right, when it comes to machine learning. And there are different algorithms. There are algorithms available in most machine learning platforms out of the box. And most machine learning platforms will also allow you to go ahead and they will allow you to build your own algorithms as well, right? So typically speaking, what happens is these algorithms are usually built in Python or R program language, R code base. So, and you would implement these as, Python variables or Python applications over any machine learning platform or data science or AI platform, which is what we do as well in Splunk. We have our own machine learning toolkit, and that machine learning toolkit allows us to understand the data and also predict the data, right? Predict what's going to happen in the near future. Now, neural networks are another very important part of the whole artificial intelligence and data science space. So neural networks are nothing but, your brain at the end of the day is essentially a biological neural network. And when you talk about neural networks, when it comes to data science or artificial intelligence, you go ahead and what you try to do is you're trying to build something on top of an application, right, which mimics the behavior of your brain. So you're trying to build a data platform, an analytical data platform, which is self-aware and which is able to identify what exactly, right, is required of a particular use case, and then adapt to the parameters that are supplied for that particular use case. And one of the use cases for this is you can basically do something along the lines of predictive analytics. And I'll actually show you a demo for predictive analytics, right? So this predictive analytics is basically what helps you to go ahead and it is what helps you to analyze outcomes and predict outcomes in the near future, right? So those are all the fundamental building blocks when it comes to data science or artificial intelligence or big data analytics. These are all interchangeable terminologies, whatever it is that you want to call them. I tend to stick with the terminology artificial intelligence mostly because it's an all-encompassing term. So what are all the use cases for AI, right? Powered by big data, powered by data science. Well, transaction monitoring is a very important use case. So what is transaction monitoring? What exactly are we doing when it comes to transaction monitoring? Well, transaction monitoring is nothing but we want to predict, right, what's happening to our sales, right? So let's say, for example, you're a company and you're selling, let's say you're selling video games on the internet, right? Or you're selling something else. Maybe you're selling something like you're selling grocery products. You specialize in selling different types of rice. Now, when you do this, right, and when your customers are logging on to your online platform and they are buying rice from you, you want to predict customer behavior. You want to understand, why your customers are buying from you, right? And how your customers are buying from you, right? And when your customers are buying from you. So you need to understand customer behavior so that in the future, if the sales goes up drastically or comes down drastically, you'll be able to respond to that appropriately, right? So that's transaction monitoring. Predictive analytics is you use data analytics platform to build and for you to understand what's going to happen in the future so that you can be prepared for it. Media and entertainment is one of the best use cases for data science and artificial intelligence. Classic example is apps like Netflix and Spotify, right? And for example, using something to the tune of, let's say, a personal assistant, right? So something along. Oops, sorry. When I said personal assistant, that was basically a trigger word for my Amazon Echo device sitting on my desk. So it happened to trigger. Sorry about that. Anyways, so for personal assistant devices like your Google Home device or your Amazon Echo device or whatever it might be. Healthcare and diagnosis treatment is also a very important aspect of data science. In fact, today, more than ever, data science plays a huge role when it comes to healthcare diagnosis and treatment. If you want to know the applications for data science in healthcare, the times we are living in right now is a fantastic example. Every day you go on to a website like covidindia.org or whatever, right? And that entire website is all based on data science. It's all based on big data analytics. I can actually show you. You might be already familiar with this, but let me show you here. I'm going to COVID India, COVID-19 India.org. So hopefully this is right. Yeah. So if you look at this website is out and out. Whatever is coming up here is on the basis of data science, right? And you can actually see, the trends that are available here, the numbers for every state and city wise. And if you look at what is happening here with this particular website, you can see that the data that is being used for this particular portal is based on open sourced GitHub data. And GitHub is nothing but it's a crowdsourced, data repository. It's a version management tool and it's a data repository. If I click on this, it directly goes to the GitHub project that is responsible for this particular website. And I can see what the information is. I can directly go here to the code base and I can directly look at what exactly is happening here, right? So these are all of my update dependencies. This is the public data available here. I can go into the public data. I can look at the flags, maps. I can look at all the SVG and the JSON files, right? This is an open source project, and the data for this is built out and out based on public data. Now, the other thing is the actual database, crowdsourced patient database. This is also big data stuff right here. So there is a source code available for this on GitHub. So there's an API that is provided to this, right? So you can actually see the API here, the workflows here. And you can see, right, all of this data is represented in JSON. So JSON basically stands for, JavaScript object notification. So it's a Java-based structured data. That's what JSON is. So as you can see, all this information is logged in public data. In fact, I can open this as a CSV, and I can look at this as a CSV file as well if I wanted to. So this is all CSV files. I can get access to the CSV files, and I can go look at the API for this particular set of data as well if I wanted to, right? And there's documentation available for this API. If I want to, build an application on top of this open source data, it's pretty easy because there is a React side repository. This is React.js repository that's available for this particular application, right? So as you can see, the entire platform is nothing but the app works primarily on the basis of data science, right? So that's a classic example for healthcare. I mean, it's not just this website, but every country has, both public facing and, private individual based initiatives, portals that are run to discuss the, coronavirus pandemic. Another useful use case for data science or artificial intelligence is IT security. So IT security is a fantastic use case. So there are plenty of products available for data science or for artificial intelligence when it comes to IT security. The best example for that would actually be the antivirus application that you would have installed locally, right? Those antivirus applications contain a lot of data modules, and those data modules, right, will deal with the analytics of whatever behavior that is being predicted from your local computer or from your local node, right? Another application is to actually go ahead and do threat response. So there are products like Phantom, or there are products like ArcSight, which are all basically SIEM platforms, right? So there are security incident management platforms. We respond to security incidents on the basis of data science, right? So those are some of the use cases for data science and for artificial intelligence. I am going to show you an example using some data sets right now, right? These data sets are, our own proprietary data sets. They are basically data sets that belong to the IT infrastructure of a company. Now, using the IT infrastructure of the company, I'm going to run some algorithms. I have some regression analysis algorithms. So I have a linear regression algorithm, which is good for simple, regular repeating patterns. I have a random Forester algorithm, which is good for complex anomalized data. I have a gradient booster regressor, which is good for complex data with patterns. I have a logistic regressor, right, which is for category analysis, which is for severe service severity prediction, right? So I'm going to show you these, algorithms, and I'm going to show you how I am going to train, my data using these algorithms so that I can do some predictive analytics work, right? So I'm going to first show you the easy items that you can relate to. So I'm actually going to sort of switch the order here. The order here is, I was about to show you the predictive analytics example first, but let me first show you Netflix and Spotify recommendations. That's actually a very good example for data science, right? Used in consumer entertainment applications. And then, of course, I'll try and show you Spotify. And then, of course, I'll try and show you an IT service management tool using Splunk. And I'll train some algorithm data on top of it. And I'll try and show you how that works. So I'm going to take 5 minutes to show you Netflix and Spotify, how they work, and then we'll quickly jump into an IT. So before proceeding with a simple, I know most of you are on a YouTube channel, so you're probably not able to interact with me directly. But I'd like to ask, right? Does anybody understand what Netflix or Spotify is? You can, you can probably go ahead and you can type it out on the chat window on YouTube, and I can go ahead and I can respond. So anyone has an idea as to what exactly is Netflix or Spotify? Any users for Netflix or Spotify here? I would assume you're all college students, so it's quite likely that you might, be pretty familiar with apps like Netflix and Spotify. All right, so I'm not exactly sure how interaction is going to work here. Actually, let me try and go back to the YouTube link. I'm just realizing that I am not on YouTube, so maybe I should browse the YouTube channel here so that I can probably interact with students here. So let me mute the YouTube channel. All right, so let's see if there's live commentary. Oh, comments are turned off on the YouTube channel. That's unfortunate. Okay, nevertheless, never mind. Sorry about that. Now, let's go ahead and talk about Netflix first. I'm going to open Netflix, all right? And I'm going to show you what Netflix is. Share content and oops, some movies starting to play. All right. So this is Netflix. Netflix is a simple, media platform. It's a movie platform, right? Or an OTT platform, as they would call it. So if you notice, this Netflix account is used by a bunch of people. It's used by me, my family, my niece and whatnot. So the main account holder is me. And if I go into my account, you'll notice that my account has a bunch of recommendations. Now, these recommendations, they're all based on data science. They're all based on artificial intelligence. So it seems that my recommendations are mostly Hollywood movies because that's mostly what I seem to be watching. And it also seems that most of my recommendations are all basically action and thriller movies and science fiction movies, which is what I predominantly seem to be interested. Now, these things come to be because of my user behavior. My user behavior is analyzed by, Netflix app. And this Netflix app is basically recommending things. So look here, it looks like, I watched something called Sabrina. It's a horror movie. So there's a lot of horror movie recommendations as well coming up for me, right? Now, the other thing that I want to show you is, let me go into another account. This is the account of my niece. I'm going to go into her account. Now, if I go into my niece's account, right off the bat, you can actually see her recommendations are completely different to mine. Her recommendations are all romantic comedies, and it's understandable because she's a 17-year-old teenager. She's only interested in romantic comedies. She's interested in drama. So it's only drama and romantic comedies that are being recommended on her account. And you'll also notice that, her recommendations are all basically just Indian movies, mostly Hindi movies. There's not much Hollywood action going on in here, right? Like my recommendation. It's mostly just Hindi movies, and it just, it seems to be pretty different, radically different compared to mine. I can also go into my mother's account, and you'd actually notice that my mother and I have slightly different tastes, but they're very similar. There's a lot more Indian movies here, recommendations, but there's also a lot more crime dramas, right? That are a part of her account. So this is typical data science. All of these algorithms are basically being used, right, using simple artificial intelligence modules. And Netflix is very intelligently recommending what I need to watch. Similarly, right, I'm going to show you another application here. This application is called Spotify. And Spotify is a music application, just like Netflix is a movie entertainment application. Spotify is for music. And Spotify presents 6 playlists for you. And these playlists are, curated over a period of time. And you can see my playlist, the first playlist is all 90s hip hop music. That's what these are all. And my second playlist, they're all basically pop music or traditional, pop music. Playlist 3 is old music from the 70s, 60s to 1980s. Playlist 4 is, again, older music, but these are all rock music and whatnot. Playlist 5 is all, again, this is older music, but this is mostly romantic love songs. And playlist 6 is basically Indian music. It's all mostly Tamil music, right? So you can actually see, right, how exactly, right, a particular set of applications are actually recommending, a recommending behavior. So let me share my screen here again, right? So far, we've looked at, media applications like Netflix and Spotify and whatnot, right? Now, let me go and let me go to my browser here. Browser. Oops, did I close my browser? No, I didn't. Okay, right. So we are going to go ahead and we are going to look at an IT service management use case. So let me go here to my, actually, it looks like YouTube chat is now enabled. So allow me to go on to YouTube chat so that I can follow, if anybody is, let me go here, sorry. Go to a new private window, maybe. Oops. Hang on a second here, I'm fumbling with my browser. All right, so let me go to my, right. So I'm going to go ahead and open an IT service management application. Let me go fetch the URL for the application here. It's IT. Oops, looks like that's not the right one. Let me check. Yeah, there's an S missing there. All right. Now, I'm going to log in into my IT service management application here. Now, this IT service management application. All right, so what this IT service management application does is pretty straightforward, right? So all that this application does is this, right? Actually, I'm gonna have to browse the YouTube channel in another browser window here because I'm afraid to hinder this. All right, so let me close all the other irrelevant windows here, right? So, all right. So we're going to look at a simple IT service management use case. So what is that IT service management use case going to show us? Well, all that the IT service management use case is going to show us is we're going to look at the online sales of a company. So I have online sales. So this online sales is basically going to be the sales of a particular company. If I click on the online sales of the company, I can clearly see that there are some KPIs. KPIs are nothing but key performance indicators. Now, this is a typical IT service management use case, right? Now, what's happening here is that if I go and if I select some KPI, for example, let me select the purchases KPI here. So if I select the purchases KPI here, right, I can see what are the figures for this KPI. I can click on the views KPI. That tells me, how many customers have viewed my product. Volume KPI tells me how much of traffic volume I am getting into my store. There's also a support web farm service. Now that service gives me information about, the actual web farm, the server farm, which is, making it possible for me to run this website. Now, this storage free space is basically nothing but it's talking about the parameter of free storage space available in my service, right? And then it also goes ahead and it makes use of CPU utilization. So basically what I'm trying to do is this. If a business needs to run and if a business needs to sell something online, its server farm requires, right? If the server farm is not running comfortably, it means that the business, the sales cannot go on comfortably. So I have assembled all of these KPIs in order for me to monitor my server infrastructure, right? Classic data science applications. I can actually show you the data behind it. If I go to the search here, I can show you what's the data behind this as well. I can go to ITSI summary. Okay. So you can see all of this is just sales data. It is all IT service management data. I've taken all of this data, and what I've done here is I have put together this entire IT service management panel in an application, right? And this application is essentially helping me understand what's going on, right? That's what is happening over here. Now, the cool thing with data science is that data science allows you to exploit certain opportunities, right? And most importantly, I can exploit some opportunities along the lines of artificial intelligence. So how do I make use of artificial intelligence here? Well, I have a machine learning add-on that is available here. All right. So the machine learning add-on is able to run some algorithms and it's able to actually understand what's going on. All right. Now, let me show you how I am going to configure that. I'm going to go to my service configuration here. And I'm going to go to online sales and then, well, not online sales. I'll go to support web farm and I'll edit this service. And let's see. Okay, so now look at this here. I've got predictive analytics here. Now, what I want to do is I want to make use of my machine learning toolkit. And this machine learning toolkit is going to allow me to analyze the data on the back end, right? And that data is going to be analyzed by the machine learning toolkit. And the resulting looking for the right word here. The resulting output of this particular module is nothing but I am going to use some kind of rudimentary artificial intelligence to predict what is going to happen in the next 30 minutes. What do I mean by that? You see, right now, I have a service health score here. The service health score for support web farm is 70%. Now, is my service health going to be 70% in the next half an hour? No. But, what I'm going to do is this, right? I am going to go ahead and I am going to try and predict what's going to be the service health in the next half an hour. So that's called predictive analytics. It's a very minuscule and simpler form of artificial intelligence, right? So I'm going to use the last 14 days worth of data. I'm going to choose an algorithm. In my case, I'll choose regression algorithm and I'll choose linear regression and I'll hit the train button. When I hit the train button, you can actually see the split for training test 70-30 it says. What is this 70-30? The 70-30 is nothing but I want to use 70% of the data to train the data, to train the algorithm, and I want to use 30% of the data to test the algorithm, right? So, that's what I'm trying to do here. So I've already clicked on the train button. In the back, the training is happening. You can see it's going round and round and round. It's creating a model. What exactly is it trying to do right now, right? It's trying to build a data model. That data model is nothing but it's trying to analyze the different patterns and behaviors of this particular data. And it understands, look, it has completed. It has already completed this regression, right? And now it says model created, see test model below for details. So this is the model that it has, come up with. Likewise, I can also use other formulas as well. Random forester. I can train this on random forester. Same split, 70-30 split when it comes to, random forester, right? So I've just hit the train button, right? And so the training is happening right now. The algorithm is basically using the data to train itself, and that data is now basically predicting, what's going to happen over a period of time. So now that I've done this, let me save this and let me actually show you the output, the result of this, right? So if I go to dashboards and if I go to predictive analytics, right, you can actually see in predictive analytics, right, I can actually see my services are available. I'll choose the support web farm service. Now in the support web farm service, I have two models that I've created. So I'm going to choose the linear regression model. So using the model that has been predicted, look at the heading here. IT Predictive Analytics uses learning to predict health score value of a selected service. These are going to use historical KPI and service health score to basically, see what the service is going to look like in the next 30 minutes. And voila, in the next 30 minutes, right, it says the service health is going to be 100%. What is the service health score right now? Right now, the service health score it was 50 something a few minutes ago. So right now, storefront web farm is at 50%, right? It used to be 56% or whatever. It's now 50%. And eventually, this is going to go up. It's going to go up in the near future. It's going to go up to 100%. That's what is going to happen, right? I mean, this is not the only model. I can use another model, for example, random forester. I can use that model, right? And that model can be used to predict what's going to be the service health of the support web farm. Now, a different algorithm gives me a different output. The algorithm now tells me, according to random forester algorithm, it says the service is going to be 83.4%. Guess what? I think random forester is more suited to this particular piece of data, simply because the data actually is it fits the type for random forester. Remember, random forester, we talked about this, right? Random forester is simply for complex unnormalized data. So our data right here is actually complex unnormalized data. That is what this is at this point in time. So we're able to easily understand, right, what exactly is going to be the future of this particular piece of data, right? So I can go to another service. I can go to the online sales service. And in the online sales service, I have only one model that has been trained, linear regression. So right now, the online sales service health score is 52.5%. Let me refresh this again. If I refresh this, it might change a little bit, right? So see, it's now at 64%, not 52%. And predictive analytics clearly tells me in 30 minutes time, it's going to be at 53.94%. So this is a typical use case. Predictive analytics is often used in the field of data science for us to predict what's going to happen in the near future, what's going to happen in the far future, for demand planning, for forecasting, right? All of these items are pretty interesting. They are useful tools for all of these use cases when it comes to business. Now, it's not just that. I can actually go ahead and do a lot of other things. For example, I can actually do support ticket tracking. These are all, the problems that you see in front of you. These are all chronic problems in my environment. So these chronic problems in the environment, they're all being noted in the, service management section, right? And that service management section is reporting all these issues. I can take ownership of any issue. I can go to, for example, this issue, and I can say acknowledge this issue. If I acknowledge this issue, right, I've taken ownership of this issue right now. So what am I going to do? There are only 3 servers running in the storefront web form. Looks like there needs to be more than 3 servers running. So how do I deal with this issue? How do I work on this issue? Well, working on that issue is outside of the scope of this application. But typically you'll engage some kind of an IT support staff. Typically you'll go ahead and figure out what's happening with the particular environment, and then you'll go ahead and you'll fix the issue. Now there are some actions that I can take here as well. For example, I can ping a host, so I can simply go ahead and specify the host value here, and then I can say done. And it's going to ping that host. It's running that action. It's actually using a simple ping command to ping that host to see if that host is actually alive and running, right? So it can be alive and running. I can view the activity. If I click view activity, it goes to my activity, and look, this is the result of the ping command that I just ran. See? So, I can do a bunch of things like this. I can then say, okay, the server is alive. I can even say resolved, and I can close this issue as well if I want to. Not only that, I get to have a lot of analytics data in front of me. For example, look at this event analytics monitoring here. I can go ahead and I can monitor my entire IT health environment here. So look at all the data that has been put in. This is my rules engine that tells me what time it takes for me to process the data. This is all the processing times. This is the health check. What is the health of my current environment? This is my running mode, right? I can look at it real time. I can preview, right, the number of times the rules engine is going to start. I can also go look at the activity channels over here to see what exactly is happening. I'll also have another event analytics audit dashboard over here. So this dashboard again gives me a lot of very interesting information about how many events I've indexed, how many episodes I have, what is the noise reduction, right? When it comes to events to episodes, episodes are nothing but my chronic problems here. What is the mean time to resolving an issue? What is the maximum time to acknowledge a particular issue, right? What exactly is the ownership and status acknowledged by user? So these are all analytics information that I can actually go look at this point in time, right? Now, not only can I do that, but I can also go ahead and do this. I can go look at a service, and I can go ahead and open a particular service. Let me open the storefront web form, and I can jump into a deep dive so that I can do an analysis of all of the services here, right? So these are all the services. Let me reduce the time frame. I'll just reduce the time frame here by 4 hours or something, because I only have this data around for the last 4 hours. So as you can see, I can see the health score of the service. I can see the CPU utilization. I can see the errors. I can see the memory free space. I can see the storage free space. Storage free space seems to be dipping in the near future. So let me reduce the time frame here to 60 minutes. And I can actually see in the past 60 minutes, storage has taken a dip. See? I can try and understand why this is happening, right? So I can go look at the data behind it as well if I wanted to. I can look at the graph rendering options. I can make this logarithmic. I can make this as, the gaps to be disconnected, right? Or if I don't like the disconnected gaps, so I can go ahead and have the connected apps and then, render this as much as I want to. So instead of looking at actual values, I can also go ahead and take a look at the logarithmic representations of my data as well. So typically, this is what we use in an IT enterprise when we say we're using data science to solve this problem, to solve that problem, and whatnot, right? So, all right. I've been noticing that there is actually a lag between the Cisco WebEx session and the YouTube session, which is understandable because it doesn't happen real time. There's a 15 to 20-second lag or something like that, which is perfectly fine with me. But I would just like to, you know, pause at this point in time because I've been continuously talking, and I would like to ask the students or the staff or the faculty if anybody has any questions, because we've pretty much come to the end of the presentation. I just have a bunch of things to discuss about future trends when it comes to, data science and artificial intelligence and all of that. But before I talk about future trends, does anybody have any questions so far? Any questions on any of the things that we've talked about?
Dear students, you are welcome to put forward your queries to our eminent speaker. You can ask your questions.
All right, there's a question from Isaac Sajjan. How machine learning helps data science? Well, there's no such thing called data science in the sense that data science, machine learning, they're all related terminologies. Data science is the very broad field of, using data to study an environment or a business or an outcome. So machine learning is simply about statistical algorithms that are used to go ahead and predict the outcome or analyze the possibilities of data, right? So question from Mohammed Yusuf. My question is how to become a data scientist. What are the needs and requirements to become a data scientist? Well, if you want to become a data scientist, as in if you want to become an actual data scientist who works in the field of STEM, I would argue that you will need to go ahead and you will need a degree in, you'll certainly need some kind of an education in mathematics, especially in statistics, because in my personal opinion, statistics is the foundation for anything related to machine learning, right? And so you might want to make sure that that your game on statistics is actually pretty strong and you do well in stats. When it comes to computers, when it comes to computer science, you should certainly be familiar with Python and R programming. At least right now, that is where things are headed to. In the world of data science, not knowing Python is not actually useful at all. So it's going to be counterproductive. So Python and R programming are critical building blocks for a career in data science. And of course, if you want to become a data scientist, and if you want to work in STEM, you might certainly require a PhD. But if you're talking about working as a data scientist in a tech company like Amazon or Apple or Microsoft or CTS or TCS or whatever it might be, in which case, of course, your Python programming skills, your JavaScript skills, Node.js, React.js framework, you have to be familiar with all of these. Be familiar with how relational databases work, even though we don't use much of relational databases when it comes to data science. And also be familiar in general, with writing code, Python code, Java code, and React.js and Node.js framework. Those are pretty useful skills. So what is the first step I should take towards learning data analytics? That's a question from Krishna Priya. All right. So first step you should take towards learning data analytics is utilize all the free resources. There's a bunch of free resources available on the internet. Go look at YouTube videos. That's the easiest thing that you can do. You have a phone in your hand. Your smartphone has internet. So go to YouTube and look for data analytics and data science YouTube videos and start watching videos. Start learning programming, start learning Python and R programming, specifically Python and R programming. And also brush up your skills, math skills, especially your statistics skills, right? So all these algorithms that I actually talked about, right? In terms of your regression algorithms or in terms of your category analysis algorithms, right? Make sure that you brush up and you're familiar with the statistics side of mathematics. There's a question from Ria Wins. Does mathematics play a major role in analytics? Mathematics is the foundation for analytics. Without mathematics, there is no analytics at all. Analytics at the end of the day is just math implemented using technology. So if there is no mathematics, there is no analytics at all. Tell much more about how Netflix works and how it recommends the things to watch. Another one is, what algorithm does Netflix provide in the subscription? Well, I think I already showed you an example of how Netflix works. Netflix purely works on the basis of your past behavior. The more you spend time, the more time you spend on Netflix, the more Netflix is able to accurately predict what kind of content you're going to watch. I'm pretty sure, whatever algorithm Netflix uses, it's going to use those algorithms on the basis of metadata. Netflix will have a lot of metadata for every movie or series that you're going to watch. And it's simply going to analyze the metadata, and it's going to see what kind of behavior that you've displayed in the past, and it's going to make use of that. It's going to make use of that in order for you to make predictions, future predictions on what you might like. As for what algorithm Netflix uses, that's proprietary information. I think your guess is as good as mine. There's certainly going to be regression analysis. There's certainly going to be category analysis. There's going to be behavior analysis. But what algorithm they use, I don't think they're going to use any sort of standard algorithms. Those might be their own, those algorithms might be their own proprietary algorithms that they might have written using their own data scientists or statisticians. So honestly, I don't know what algorithms they use. And I don't think anybody can know as well, because that's proprietary information. That's like asking Coca-Cola, what is the formula to make Coca-Cola? I mean, I'm pretty sure everybody has a reasonable common sense idea as to, what are the ingredients to make Coca-Cola. And there's plenty of recipes out there to make a soft drink like Coca-Cola. But if Coca-Cola going to, Coke going to reveal the formula to make their drink? Not necessarily. I don't think so. Is AI linked with data science? Some negative reviews posted get deleted automatically. We're talking about politics, Femil Sam. So whether or not a company or an organization is going to delete negative reviews, that is not in any way connected to artificial intelligence. That is people doing regressive things. So that is outside of the scope of our discussion, unfortunately. So if you post a negative review about a product, in their website, and if they delete it, that's a matter of ethics. So, data science, artificial intelligence, everything, big data, everything is a tool at the end of the day. So you can use the tool to be productive, or you can use the tool to be regressive. So it's up to the company, it's up to the organization and their culture that determines, how it's going to work. Any other questions so far? All right, it looks like the flow of questions have stopped. So let's wrap up this session, right? Let's talk about what the future trends are, right? So, okay, question from Giant J. How much can we earn in this job? Well, what is going to be your salary depends upon the company you work for and your performance. So I cannot tell you how much you're going to earn. You're going to earn as much as the next person. or maybe you're going to earn more than the next person or lesser than the next person. That completely is up to the market. So starting salaries for data analysts are somewhere around the lengths of, I would assume they're around the ballpark of about 5 to 6 lakhs per annum, but it really depends. It really depends on what kind of skills you have and also what kind of companies you're working for. If you work for a startup, you might get paid less, but you might get better experience and better exposure to the product side of things. But if you work for a reputed company, you might not necessarily get a lot of product knowledge. You might be just another cog in the wheel, you know, but you might get paid more. So it really depends who you want to work for and what project you're working for as well. All right, so let's look at some future trends when it comes to data analytics and artificial intelligence. There's a company called Neuralink, which is a company set up and run by Elon Musk, the billionaire, celebrity, philanthropist, person. So you might know Elon Musk uh, um, uh, from companies such as the Tesla car company, the electric car company, and things like that, right? And uh, Neuralink is basically nothing but it's a chip, it's a product that can be directly embedded onto your brain, and Neuralink can stimulate portions of your brain, and it can communicate with your brain. And Neuralink right now has very, very good use cases. So, for example, reanimation of activity to assist people with disabilities. That's a very, very good use case when it comes to Neuralink, right? Another example is palliative care, right? So palliative care is essentially, at the end of the day, right? It's assisting people with chronic illness, right, and helping them survive through that chronic illness. So that's palliative care, and Neuralink kind of products are very, very, useful when it comes to palliative care. Um, there is a question on convolution neural network here. So convolution neural network, is it? Okay, let me quickly go ahead and check the list of questions here. Convolution neural network. I'm not really sure if I understand correctly what it means by convolution neural network. So convolutional neural network, is it? Well, from what I understand, convolutional neural network is basically a strategy when it comes to deep learning. So, so that's basically what convolutional neural networks are all about. You can use a predictive image or a fake image or fake data for you to analyze patterns and for you to understand behavior. In fact, that is what I did right now. I actually showed you some sample data, which is a typical example for a convolutional neural network. What I actually built was a simple example using some data that was generated using scripts, and I ran a predictive algorithm on it for me to analyze the output of that algorithm sometime down the line in the future. So next question. Sir, we are hearing news like Facebook played a role in US president election. Whether there is the role of data analytics on it? Well, Facebook as a platform, as an application, is out and out based on data science. So if anybody is or if you're going to talk about applications like, for example, if you're going to talk about applications like Instagram, if you're going to talk about applications like any other social media platform like TikTok or whatever, all of these applications are essentially, at the end of the day, their foundational data is all based on data science, right? So data science is the bedrock, the platform on which all these applications actually work. So next question from Mohammed Yusuf. Can you tell me the difference between data analyst and data science? There is no difference. Data science is the field of study using data. Data analyst is essentially a person who analyzes data to arrive at results. What are the steps involved in an analytics project? Well, it's a very broad question. You need to basically define what kind of data analytics project you're building, but any analytics project will require you to build a repository. So you'll need to index some data and then build a repository, and then you'll need to write code for an application, like for example, a Python application which will query that data, and then that application will then give you the necessary results that you need. And of course, you're going to have to refine that data, and you're going to have to go ahead and you're going to have to work with that particular data in the context of that particular application. Whether deep learning is better than machine learning for data science. Well, deep learning, machine learning, these are all interchangeable terminologies. Deep learning is nothing but using analytics to build data models or data sets. So there is no such thing as, I think a lot of people, one of the problems with the field of tech and computer science is that companies tend to throw in a lot of jargon. So there's a lot of noise amidst the clutter. So try and ignore the noise and try and spend some time understanding the fundamental concept. So deep learning is essentially nothing but deep learning is another name for complex algorithm that are going to look at hierarchically structured big data. That is all deep learning is. So deep learning does, complex pattern analysis. That's all deep learning is all about. So there isn't really much of a difference between deep learning and machine learning. Machine learning is, at the end of the day, essentially, machine learning is the foundation for everything else, like neural networks, deep learning. So without machine learning, it's pretty difficult for you to implement any of these, products or any of these technologies. All right. Any other questions before we wrap up the day? Great questions, by the way. I understand that there's a lag between my WebEx presentation and YouTube, so I'm going to wait for 15-20 seconds so that there are more questions that come my way. Because I can see, that there's a bunch of questions. Hopefully, there will be more students who will have more questions. So if there aren't any more questions, I think we can wrap up the session. I think we started at 3:10 and I've slightly gone over my designated time limit of 1 hour. So sorry about that. But yeah, I think we can wrap up today's session if we don't have any further questions. You have my email contact information. You also have my LinkedIn contact information. So add me on LinkedIn, send me an email if you have questions. I'll usually respond to email questions within a 24-hour window. If I am busy, if I am traveling, it might take a little bit more time. But yeah, that's pretty much it as far as today's session is concerned, if we don't have any further questions.
Dear students who are with us in WebEx, kindly ask the questions if you want to ask.
Thank you very much, sir, for your valuable.
Jefferson, you can carry on.
Good afternoon. Good afternoon, sir. First of all, I am Andrew from second year CSC department. Thanks for this wonderful webinar. I have one simple question. How do you know which kind of algorithm, regression algorithm we have to use? Is our job as a data scientist to look at the data sets and find which algorithm to use, or what is that case?
Yeah, the kind of algorithm that you need to use depends upon the data that you're putting into your analysis. So every kind of data is suited for, or I mean, every algorithm is suited for a particular kind of data, right? So if you're going to be using linear regression, then a particular type of data is suited for linear regression. If you're going to be using Lewandowski, it's suited for highly complex data with a lot of noise. If you're going to be using category analysis, it's used for structured data that do not have definitive boundaries and a moderate level of noise. So what algorithm you need to use? Either you will know already because you have you have a statistical experience on handling data, or if you don't know what algorithm to use, you're going to have to consult a statistician, and your statistician will essentially be the person who will recommend the appropriate algorithm for a given piece of data. And those algorithms will need to be tuned as well, because all algorithms will have variables, will have parameters that you can tune. So you'll need to tune an algorithm to work for the data. So that depends on what kind of output you're expecting for that particular data. So if I'm expecting predictive analytics, then I need to tune my algorithm in one way. If I'm expecting, to find out any sort of outliers, then I'll need to, tune my algorithm in a completely different way. So it also depends upon the intended use of the data as well. That will define how the algorithm is going to be tuned.
Thank you, sir. Thank you for your valuable time and resources, sir. Thank you.
There's one
Thank you,
question
Andrew.
on YouTube. The question is from Ansel Allen. How does AI interrelate all apps and display us advertisements for online shopping and other stuff? That's purely on the basis of pattern analysis and behavior analysis. So if you know, all websites use something called as a cookie. A cookie is a simple text file. It's a storage mechanism to store user behavior. So as long as your cookies are going to be available on the browser, the app that you're accessing, in this case, it's a website, knows your behavior already. So when you browse Facebook, right, if you've used your Chrome web browser on your phone, and if you've tried to buy, let's say you've tried to buy mobile phones, automatically there's going to be cookies for mobile phone purchases on your phone. So when you browse Facebook, you're going to get advertisements on Flipkart or Amazon about mobile phone offers. So that's based on cookies. So cookies will predict your user behavior, and that user behavior is what is going to be used. So I don't think there's much of AI that is involved when it comes to advertisements. There is a moderate amount of machine data that is involved, but AI is not really required in that sense, because you're not really predicting anything. You're just blindly throwing, data at people so that they will potentially end up buying. So it's just like cold calling, right? For telemarketing, you call 1,000 people and 3 or 4 people end up buying your products. That's what it is, actually. All right, I think we're pretty much done with the questions here. Question from Krishna Prasad: is any way augmented reality related to data science? Everything is related to data science. Augmented reality makes use of real-time data science. We make use of real-time data analytics and real-time data stream processing and real-time predictive analytics for augmented reality. Without the field of data science, there is no augmented reality, there's no virtual reality, there's no VR games, none of that. It's all based on, it's all essentially based on, at the end of the day, it's based on data science. All right, I think we can wrap up today. That's the questions we have on.
Thank you so much, sir. So we will carry on with our thing. Over to Kokla ma'am. Kokla ma'am.
Good afternoon, sir.
Okay, thank you.
Vasugi, do you have questions?
Yes, sir.
You can ask your question if you have. Vasugi?
Okay, sir. Okay. Myself, Manikya Vasugi from pre-final year. I'm doing Computer Science Engineering in Pondicherry College of Engineering. So first and foremost, I would like to thank you for spending your valuable time by answering our questions. Thank you, sir. And this session is very informative. And my question is, how the weather is forecast, how the weather is predicted by using data science. Will they take the data which is already collected or the current inputs?
Well, prediction of weather is not just based on data, it's also based on intuition as well at the end of the day. So what you might actually expect to do is you will look at some pattern analysis. So the primary mode for weather prediction is pattern analysis. So you look at similar patterns that have existed at a similar time frame in the past month, year, week, whatever. And then you look at the current behavior of the environment. What is your cloud structure, what is your humidity levels, and what is your wind direction, and other environmental factors. And you'll correlate these two. So correlation is an important part of weather prediction. So whatever correlation that you want to do, you'll correlate with existing data and real-time occurring of events in the environment, and you'll try to predict weather. That's how I understand weather prediction works.
Okay, thank you, sir.
Kokila ma'am, over to you.
The students for your presence, and you made this event a very successful one. Thank you, faculty members, for your valuable participation. Once again, I thank you, our speaker, for his valuable time for us. Now, I hand over our section to our HOD, Dr. A.J. Deepa, to deliver vote of thanks.
Thank you, Kokila ma'am. I'm very happy to conclude this session, a great session with a vote of thanks. Very good afternoon to one and all. First of all, I would like to thank Almighty for conducting such virtual seminar in a successful manner. I thank our chairman, sir, Sri Pon Robert Singh, sir, for giving us opportunity to conduct a virtual seminar, and he gives a lot of support and guidance for all the activities what we are conducting in our department. Thank you very much, sir. And next, I would like to thank our principal, sir, Dr. Nadarajan, sir, for his constant support and guidance to conduct this seminar, a successful one. Thank you very much, sir. And I would like to thank ICT Academy for arranging an eminent speaker for this session. Thank you very much, ICT Academy, and my sincere thanks to Mr. Rajkumar from ICT. Thank you very much, sir. And next, I would like to thank our guest speaker, Mr. Dilip Muralidharan, Senior Technical Inspector, Splunk, who accepted the invitation and spent his valuable time to share his view about the data science to our computer science department and other department students, and very patiently he was explaining all the doubts which is asked in the YouTube channel as well as in the Thank you very much, sir.
Thanks.
Thank you.
Once again, on behalf of Pondicherry, I thank each and everyone. And I'd like to thank our faculty members as well as students who participated in this webinar. Thank you very much once again. Thank you.
Thank you, ma'am. Thank you so much, sir. Kind attention to all participants, please. Feedback form is enabled in YouTube distribution box. All participants are requested to fill the feedback form. It will be enabled for 15 minutes. After submitting your feedback form, you will receive the e-certificate soon. Once again, on behalf of CSE family, I extend my heartfelt thanks to all. Thank you, guys. Meet you soon with a wonderful session.